I'm going to show you how I'd solve valid parentheses from first principles. We're given a string s containing just these characters, and we have to figure out if it's valid, and then we have these three rules to help us out. To make things concrete, I want to first think about some examples, and I want to think about the simplest kind to make my life easier. And the simplest example I can think of is just a single pair of parentheses like that. So that's our first example. Now, how do we make this more complicated? So from our initial starting point, I'm realizing that we could, of course, have another pair to the left or to the right. And so we could have something like this. And if I generalize for a moment, what I realize I'm doing is I'm adding a sibling pair to something that already exists. So we have this existing pair, and then we just added a sibling pair to the right. Now let's think about, again, what else we could do from our initial starting point of a single pair. And you might realize it by now, it's pretty obvious. You could also have a nested pair. And so this is interesting because with just these two moves, adding a sibling pair or a nested pair, you could come up with any valid example. But again, in the spirit of keeping things simple, let's just focus on analyzing these three for now. Now that we have some examples to study, is there anything we can notice that will help us solve the problem? So one thing that seems like might be true is that it feels like a closing parenthesis will match with the latest opening one. In the first example, it's obviously true. The only closing parenthesis matches with the most recent opening one and the only opening one. And in the second example, it's also true. The first closing parenthesis matches with the most recent opening one. The last closing parenthesis, it also matches with the most recent opening one. But what about this third example? So the first closing parenthesis here, well, it does match with the latest opening one. But what happens when you move on to the last closing parenthesis? Well, it's not going to match up with the most recent opening one because, as we just saw, we just used up the most recent opening one. And so at this point, what I like to do is realize our hypothesis was close but wasn't quite right, and we need to modify it to be true. And after you look at this a little bit longer, what you'll see is that what's really happening is that each closing parenthesis should be matched with the latest unused opening one. So that's a really important point, so I'm going to write that down. I'm also noticing that it seems like I can get rid of things as I go along. So let me show you what I mean. In this example, once I see that the first pair is finished because this matches with this, I don't need to know anything about this pair to analyze the rest of the string. So as I go along, I'm tempted to just cross out the pairs that have already been used. Let's look at these two examples again in light of our new ideas, which are, number one, each closing parenthesis should match with the latest unused opening one, and two, we'll cross out pairs that have already been used up. So this matches with the most recent unused opening one. Now that this pair has been used up, we cross it out. And then exact same thing here. This matches up with the most recent unused opening one. Now that the pair has been used up, we cross it out. And now everything's been crossed out and we're left with nothing, which is good because it means everything was matched up correctly. Now to the last example, this matches up with the most recent unused opening one. Now that the pair has been used up, we cross it out. And now I'm noticing that crossing out things is even more useful than I thought because it allows us to easily see the most recent unused opening parenthesis. Now that this pair has been used up, we cross it out and we're left with nothing. Before we go to implementation, I want to show you the conceptual intuition behind these two rules we came up with. Imagine this example, and I've drawn it out like an onion so we can clearly see all of these nested layers. Now imagine we're cutting this onion with a knife from left to right, so from the outside in. Each time we cut an open parenthesis, we're going to go one layer deeper until we get to the center. Once we reach the center, if we keep going, we'll now exit each layer. And it makes sense that we'll exit the deepest layers first, since we're now going from the middle out. So when I see this closing parenthesis, I know that it should match up with the deepest unused opening parenthesis at this moment, which is this one. And then once we cut through both sides of this layer, we can get rid of it. And then we can just repeat the process. And so my point is just that these two rules, they do make a lot of sense. They're not just random things we happen to notice. We can't use a string to cross out pairs because strings are immutable. So let's try using an array instead. So here's an example input, and I'll write out the contents of the array down here as we work through the problem. At the start, we can't get rid of anything, so I'll just copy this into the array, and we'll deal with it later. Now at the first closing parenthesis, we want to know if it matches with the latest unused opening one. In this case, it does, and so we want to get rid of this pair. In our array, we've only saved the opening parenthesis, so we can just get rid of that, and now we're done with this pair. Next up, we have an open parenthesis, which we'll save for later in the array. And then at the last closing parenthesis, we can ask if this matches with the latest unused opening one. It does, and so we want to get rid of this pair. Since we've only saved the opening parenthesis, we can just get rid of that, and now we're done with this last pair. Since we've gotten rid of everything, it means that every parenthesis was correctly matched up with something. If, however, we had anything left over, that means we couldn't pair up everything, and so the string would be invalid, and we'll have to account for this in our code. So first, we're going to look at every item in our input. So for bracket in S, and I'm using bracket as a catch-all to describe all the different types of parentheses that we might encounter, and this mirrors the language in the problem. Now, once we reach a bracket, we want to know, is it an open bracket? So is it an open bracket? And then if it is, we'll just add it to our array of unused open brackets. So I'll create our array and I'll call it unused opens, and it'll start off as empty. So if it's an open bracket, then we'll go ahead and add it to unused opens. So unused opens dot append bracket. And now we just have to figure out how to answer this question. So a straightforward way to do it at this point is just to create a set of the open brackets. So I'll call that set opens, and then we'll just fill it out with all of the different types of open brackets. And then once we have that, we can just see if bracket is in opens. So is if bracket in opens, then this will be true, and then we'll append bracket to our array. So that's this part of the picture where we now have a mechanism to add open brackets to the end of our array. And then of course, if it's not an open bracket, then it's going to be a closed bracket. In the case we have a closed bracket, we need to know if it matches with the latest unused opening one, and that will be the last element in unused opens. So let me just grab the last element because we'll need it in a second. And then the other thing we need to do is we need to figure out what this closing bracket should match up with. So let's say if we're looking at the last bracket right here, we know it should match up with this open bracket. And so we need a way to figure out what that should be. So to do this, I'll just pretend that we have a map from closing bracket to the correct open bracket, and that will give us like the matching open that we want. So I'll call this matching open, and I'll pretend that we have that map close to open, and we'll pass in the current closing bracket, and that will give us the matching open we should have. Now with these two pieces of information, we can see if the matching open actually matches with the latest unused opening one. So I can just do a check here, and we can say if matching open is equal to the latest unused opening one. In that case, we have a match, and in our picture, conceptually, we want to cross out that pair. The array has the opening section, and so we can just get rid of that. So I'll go to unused opens. We've just used the latest one, and so we can just pop it off the end. And then we can't forget we have to go create this map, and so I'll write it out here. And it's super simple. We have all the different closing types, and it just maps to the correct opening type. And then finally, we have to have a check to make sure that unused opens isn't empty. Otherwise, we'll have an index error here. So I'll do, we have to make sure that the length of unused opens is greater than 0 and this condition, and only in that case will we remove the latest unused opening bracket. And then if we can't find a match for our current closing bracket, then we can return false right away. So I'll just return false. And then the last thing we have to do is check that there were no stray brackets left behind. So in this case, everything was crossed out and we got rid of everything, but that might not be the case. You might have some stuff left. And so we have to do that check. So I'll check the length of unused opens, and we want to make sure that it's 0 in order to return true. And then we'll just return the result of this expression. For our time complexity, we're going to have to look at every character at least one time. So we're going to have O of n time. And then for space, we're also going to have O of n, because in the case that you have all open parentheses or open brackets in the input, then the unused opens array is going to be the length of the input. So it'll be O of n space 2 in the worst case. Now let's go ahead and submit, and we can see that it works. Two pieces of commentary on this. One is a lot of people are going to say, oh, you don't need to create this open set, and you certainly don't. You could use the keys in close to open to achieve, functionally the same thing. But I do think having the dedicated set makes things a lot more obvious to the reader. And so at least for me, getting rid of it wasn't worth the hit to clarity. And also it doesn't affect the big O space complexity. So personally, I'd rather prefer the clearer option. And then another really important point is related to how people learn about this kind of stuff. So a lot of people are going to say, oh my God, why didn't you say the array is a stack? Of course, I could have said that. The way we're using this array is consistent with a stack data structure, but you really don't need to know about stacks to solve this problem, and that's why I didn't mention them until now. It doesn't have to be part of the problem-solving process. Someone that's a thoughtful problem solver could certainly think about using an array where you only add and remove from the end. That's not this crazy insight that you couldn't come up with. I really don't like it when people give the perception that there's some prerequisite that's holding them back. That's definitely not the case here. Thanks for watching, and if you want to see more videos like this, then please like and subscribe. It really helps the channel.